is back. And it is
it's deja vu all over again, Francine and Judy.
Yeah. So actually, talking about our host, we have a little issue that we're going to resolve. Is Brad Gilly had a very, very busy week this week. He started with us, then he went to the NASCAR banquet, and he is a little bit behind. So he was supposed to be hosting your session. He's running a little late, so I'm going to have to step in.
You really think I need a host?
I'll be quiet. Let's
just call it like it is. You haven't even met Billy yet, but yeah, you don't even need him. We're good.
So that's I told Brad, don't worry. So we'll wait patiently, and then but he's going to be back with us in probably the next 40 or 45 minutes at the latest, and we'll be able to take care of the NASCAR interview. So is Keith joining us, Lake?
I think he is. If he doesn't, then we can swing it without it. So it's okay. I'll talk for him. You know, I can try to duplicate myself.
So I'll stay on. I'll be quiet, and if there's questions, I'll pay attention to it and I'll bring it to your attention. So thank you very much. Again, welcome if you're joining us now to Race Industry Week 2021. What I was saying just earlier is that if you're on the Zoom version of Race Industry Week, you can actually ask questions through the chat button. So if you're watching us on streaming right now and you want to ask questions, please join us on Zoom and you will be able to get your question through the chat. So we're streaming live on racer.com, on YouTube and multiple channels. So it's 2 here in California. So Mr. Lake Speed, on to you.
Thank you, Francine. So introduce our buddy Bill down here. Bill Alexander is also a certified lubrication specialist and a tribologist. So there's not only one of me, right? There's 2 of us running around in the motorsports industry. So everyone, you better run and hide, right? Because it's gonna get scary.
Yeah, that's right. We can do some talking too. So don't worry about that.
Yeah. So anyway, the one thing that Bill and I really have in common, besides being, oil guys who understand chemistry and love chemistry, we're also really passionate about oil analysis, because it's one thing to have a bottle of oil and trust that it's going to do what they said it's going to do. But you may think we're both from Missouri in that, how do you know that's doing what it's supposed to do? The other day we were having the analysis or the talk about surface finish. And we were saying, okay, how do you know the surface finish is right? Well, we have this little tool, the profilometer, that can measure the surface finish, because as we discussed, you can't see it with your eye. You're talking microns. Well, same thing, that little bit of wear if you can see the difference in wear in an engine or on a gear or transmission with your eyes, it's already gone way too far. So what you really want to do is be able to measure that wear before it becomes so big that it's a problem. And that's where our friend used oil analysis. And you're right there, you got to hide it from the background filter, right? You got to be able to take that sample. And no different than any of us that go to the doctor for an annual physical. So I'm getting to be that age where that has to happen now. Take your blood, and from that blood sample, they can look and tell what's going on in your body. And Bill, why don't you talk a little bit, because Bill's got the actual practical hands-on lab experience of running those machines, because you don't have to just rely on guesswork. Kind of like the other day when Keith and I were talking about the surface finish, and you can't really do it with your fingernail. You really need one of these.
Yeah, that's exactly true, Lake. And when you look at, I've seen people do it for years as I've been in this business. Is they'll put a ball of oil or a jar of oil up, and they'll look at it and they'll go, oh, I've got fuel in it, or oh, I've got this. But we can, with the machinery and the technology that's available today, this blood test, as you call it, which I think is the perfect analogy, is going to tell us what's going on in your engine in ways that you just cannot see by looking at it, especially when it comes to, which I know Lake's gonna get to, is it's my favorite subject right now, is fuel dilution, which is a really big, it's a really big deal, and it's not something you can measure other than doing this type of analysis.
Exactly. And Keith, why don't you just, since he teed it up there, speak for a minute about the scourge of fuel dilution, because I know you see it. I mean, earlier this year, you sent me some pictures of some rings that were just destroyed with very little time on it. Just talk about that for a minute, Keith.
Yeah, fuel dilution is probably what I would like to say is the bane of my existence, because it is an every single day phone conversation, whether it's with myself or with the other guys, with Lake. This is an every single day thing. People put them together, whether it's, again, carbureted, fuel injected, whatever your system is going to be, mechanical injection. It is so critical in that initial run-in time that, that fuel trim be correct. I mean, fuel wash, fuel dilution is such a common thing today, especially on ethanol-based fuels, alcohols, E85s. I have guys trying to tune E85 engines using gasoline O2s and try to, do, say, mathematical corrections for, the stoich versus one versus the other, and they're just lost. And, when it comes down to it, when the guy sends me a, we'll say, a Pepsi bottle full of gas to look at, and, or full of oil, excuse me, and I've got a 1/4 inch of fuel sitting on top of it, go, you've got a fuel dilution problem here. You think? Are you sure? So that is, not to keep going on, it's not a scientific approach, but this is a very, very common thing. It happens. This is an every single day phone call. Talked to a guy yesterday doing, dyno work, and we talked about, dynoing the engine, and he's working on a chassis dyno, looking at the numbers, and we talked about how much time do you actually spend working on the fuel curve on this thing? How many cars a day are you running across that chassis dyno, putting your tune on it? 6, 8, 10. I remember working with Matt on his Corvette when we were working on a fuel map on that. It was driving that car every day with a drivability laptop, and it took a month to get the fuel curve right. And it's still probably not right, but too much time is, we'll say the concentration is always on wide open throttle. Most of the damage that I see done is not done wide open throttle. It's park throttle, it's idling, it's cruising. No one's really spending a lot of time looking at that, and those are the real, that's where the bulk of the damage is done, at least from what I can see.
And we had a great question here already from Tim that's actually spot on. The question is, can engine coolant temp affect oil fuel dilution, say running 160 degrees coolant versus 190 degrees Fahrenheit? Yes, the answer is 100% yes. And one of the other interesting things here too, Francique, in this whole thing is that, as Keith alluded to, all the different fuels that are out there. So every different fuel has a different distillation curve. Essentially, at what point does that fuel transition from a liquid to a vapor? And say, like a fuel like methanol, for example, which is a single molecule. It's only one thing. It essentially has a single boiling point where 100% of the fuel becomes vaporized. Now, gasoline, but being a blend, it can happen over a range of temperatures. So like most fuels will have a spec sheet that will tell you what the 10% distillation temperature is, the 25, the 50, the 90, the 100. So where I'm going with this, Tim, is the hotter the engine runs, the more the fuel is going to evaporate. So you typically are going to have more fuel wash problems in a drag racing environment than you are in, say, an endurance NASCAR type environment. So that's a big one. And the other part, like I said, is that fuel. So for the same engine temperature, so it could be the coolant temperature, say, is you're dynoing a blown engine, big boost, and so you're maybe only running at maybe 120 degrees water temperature. You could have two different fuels in that engine, roughly the same octane, with completely different fuel dilution characteristics, because one fuel is heavier, and that's a bad term, but this kind of relative things thinking, that fuel is going to need more temperature for it to evaporate. that fuel will get more fuel dilution because it's not turning into a vapor. It's maintaining its liquid form, which means it's going to get into the oil, versus a fuel that has it's a lighter fuel, has a higher Reid vapor pressure. And that's one thing you can look for. There's one number alone on the spec sheet you can look for is the Reid vapor pressure. The higher that number, the easier that fuel wants to become a vapor. So that's one thing to look at. It's a real practical way of doing it. And like Keith said, it's something we struggle with. I mean, hell, I did it myself not long ago. We were out at EFI University with Ben Strader working on some video stuff for the Engine Performance Expo in January. And, Lake Havasu City, Arizona, most of the year is pretty warm. Mm-hmm. And I've been out there a lot with Ben doing a lot of engine testing. And typically, the ethanol-free fuel around the lake isn't really great high octane stuff. So in a higher boost, higher compression engine, you need a little bit better fuel. So we decided to get some higher performance fuel. And I looked at the vapor pressure and said, it's not great, but it's warm enough in Havasu, we'll be fine. Well, the problem was it was a cold week. And we weren't running the engine that hot like we normally would because it's got a lot of boost and we wanted to be careful. Well, those two things ended up making the fuel dilution in the oil sample 4% fuel dilution, which anything over 2% gets stop. When it's really good, it's less than 1%. So we're at 4%, and that was self-inflicted. We changed fuel to a fuel with a higher Reid vapor pressure, boom, right back down to almost 1%. Just by making a change in fuel without changing the temperature. So it's one of those things, like Bill said, there's no other way to check it other than this without an oil sample. And Bill talked to me a little bit about what that test is and how that works. How do we know there's fuel in the oil?
Well, in that, you almost have to think of it. And I always kind of go back to the whole water thing. Water and fuel. There's two kinds of water and fuel: emulsified and demulsified. Meaning you can see it on the top. So it was like he said. Here's a guy and he's got a jar and there's this much fuel in the bottom. Okay, so that's free. You can see it. But fuel that gets emulsified or is actually blended into the lubricant, in some ways can be more damaging because it's really affecting the viscosity. So there's a couple of ways you can do it. You can do it with flash. Obviously if your motor oil has a flash point of whatever and it's significantly lower than that, well, then you've got fuel dilution. You can do an FTIR. There's a couple of different ways to do it, but it's so critical to know that. And not to bring up another point without fully answering your question, but it really affects the thing about fuel dilution to always remember is it is affecting your viscosity. So you need to choose your viscosity based on your anticipated fuel dilution, boost, ethanol, all these other things that are going on out there, because you're lowering your viscosity. The oil analysis is going to tell you whether your choice of viscosity is correct based on your fuel dilution. So, your 30 weight might be a 15 weight or a 20 weight, once it gets diluted based on your application. So, it's generally one of those things that I don't know a lot of people take, into consideration is when choosing your viscosity, you've got to kind of look at your application and, are you running boost? Are you running E85 or a myriad of other fuels? But then also, are you adjusting your viscosity correctly with an analysis report, and that's really what's key.
Right. Because back to ring seal, if you kill the viscosity, now it's not going to hang on the cylinder wall. And then back to Keith's favorite saying, if you had a flat tire by the racetrack, it's the ring's fault. Well, the ring's dead and they're blaming the rings. And it's like, well, no, you killed it with fuel. You killed the oil with fuel. So now it can't stay on the cylinder wall. It's washed off. Now your blow by goes up because you can see that as soon as you put more fuel in that engine than the cylinder wall can hold, it's game over. The blow by just takes off. And we saw that with the boosted engine. It goes back to what we talked about before, the surface finish. It's that ring seal soup we keep talking about. It's all of these things work together. And it's not just, I put fuel in my oil there before my viscosity's lower. okay, that's not good. Well, no. It's all these other things that knock on from there that cause problems. Increased ring wear, decreased ring seal, which is then that's that downward spiral, because once you lose ring seal, now you get more blow by into the crankcase, which that's going to kill your oil. And now your oxidation starts going up and things like that. So again, the only way to really know that is to take that sample and to look at it. And, the one nice thing about the SPEEDiagnostix kit is that, that test for not just looking at viscosity alone, but also looking at, we call it gas chromatography, GC, where we can actually look for fuel molecules, because fuel molecules are different than oil molecules. And GC lets you see that.
Kind of expand on something here, going back to just a previous thing, and then, talking about the oil analysis. We talk about E85, we talk about gasoline, nitromethane, all these different things. But something, that I've run into in my world quite a few times is the simple change of brands of fuel. I had a gentleman a couple of weeks ago, uses our products, I love your stuff, you guys are great, never have a problem, but man, I'm having a problem. I'm wearing parts out, it's doing these things. I haven't changed how I hone it, I haven't changed my oil, I haven't changed any of these things. And we go down that checklist and it's like, yep, that looks good, check, that sounds good, that seems right, man. Something changed. There's always those guys out there. So I didn't change anything, and but yet it's doing this. Well, no, you did. Something changed. It doesn't. If you didn't change anything, it wouldn't have changed. Well, I drilled down. Hey, where do you get your fuel? I buy it at the racetrack. I said, has the racetrack changed brands of house fuel? Well, yeah, they changed brands of fuel, but it's the same octane. It's 110. I go, bingo. And that simple thing. And I went back to, look at the world of hurt when it changed, fuels in the Pro Stock cars from this brand to that brand, right, that they had to go through. And that simple change caused this guy a world of hurt, even though he had no idea that it would affect it that way. Then another thing I want to touch on real quick, talking about the oil analysis test. I had a customer over the midsummer, went in, visited their shop, wanted to know a couple things about some wear that he was seeing, thinking, again, we're back to maybe got a ring thing going on. And the oil analysis found high titanium levels in the oil. They may remember this one. And that led them to looking at some other parts of the engine that they weren't looking at, and found they had not had a failure yet, but found the potential of a failure.
Yes, great point, Keith. Back to, like you said, that change in the fuel brand, it can be the same octane, but that read vapor pressure can be completely different between those two fuels. And octane will throw you off. I was, Bill, you can appreciate this. So this summer we were, had a customer that was doing the oil analysis stuff, and they were traveling around the country, following the Porsche Motorsports deal, right? Different racetracks all across the country. And of course, they have to run the fuel at the track. Of course, it's a spec fuel, or spec octane at least. Well, they found that as they went from track to track, every once in a while, like manganese would show up in the oil. There's no manganese in the oil, and there's no manganese parts in that engine. What's it coming from? It's coming from octane booster, right? It's MMT. They added to their fuel to make it the spec octane. Then they go along, and you can see it in the oil analysis. The trend, right, is nothing, boom. All of a sudden, it shows up.
There it is.
Then it starts to go away again. Then all of a sudden, they get to another track. Oh, guess what? There's a little bit of lead in the fuel, right? They went and got like avgas or something to make it have 100 octane. Boom, lead shows up. No copper, no tin, so you're not seeing any bearing materials. It's just lead by itself, which is always an indication that, if there's no bearing material besides lead, then probably the fuel. Same thing. They had to go through a whole batch of fuel because lead hangs around. As you know, it took like 2 samples for it to kind of finally clear up and go away.
Yeah. So
it's really interesting to see, Keith, like you said, it can be the same octane, but that's not going to tell you enough. And then to your point about the guys who have done the sampling of the summer, is that, like you said, a lot of people don't realize that titanium valve retainers, which are lightweight, they wear easier than steel retainers, in that titanium wear particles are pretty hard. And I don't know of an oil filter on the planet that can filter small enough that you put on a race car, at least, that can capture those particles. So as a result, all the wear throughout the engine increases because of that. So I know we got a couple of other questions here. Said, what % of race teams do you think pull and analyze oil samples from their 18-wheelers? I'm going to guess probably none. But I can tell you 100% of the Formula One grid analyzes their oil every time the car comes off the racetrack. They actually have a guy like me and Bill that goes with them to the racetrack, and they have portable oil analysis equipment, and they do all the analysis things we're talking about at the racetrack every time the car comes off the grid, because they're using trend analysis to determine when a gearbox or engine needs to be changed. They can tell what's going on. In fact, we have a customer at SPEEDiagnostix that's a big-time NASCAR team, been doing this for a long time. They've built such a trend history from doing this that they know what's normal at certain tracks for certain drivers. The A driver's style, how he brakes, how he accelerates, all that will affect the oil analysis. And they can see that, and they can know that, okay, we're at Bristol. This is normal for this driver at Bristol. And that'll be different than, say, that same driver at Kansas Speedway. But then the other driver will be slightly different than that guy at Kansas Speedway. So they can kind of look at the results now over time, because it's really what we're talking about here isn't so much the science, Bill, like we're talking about in the lab, right? We think about the lab part of it and all that. The best way to look at oil analysis is big data. Big data.
That's exactly what, here's the thing. I've said this a lot of times. One oil analysis generally doesn't tell you much. Unless, now if there's glycol in it, if the wear metals are through the roof or whatever, fine, But where it really becomes a valuable tool is trend analysis, where what that engine, what you get on that report. You can see various metals that are in the oil. So okay, my rings, you know where they come from. But when you start to see that spike, that's when you go, from it then becomes a preventative maintenance tool. In other words, that you've got wear going on in a certain area of the engine, it before it's going to affect you and affect your performance. So that is one of the most important things about oil analysis is if you do it consistently, you can generate just an incredible amount of data that you can use really to get in front of problems before, they happen. And that's when that happens one time, you'll be sold. I mean, one time when you kind of go, okay, we know this is going to happen. You get in there, you get it taken care of. That's usually all it takes.
When you think about it, if you can save one engine, right, the cost of one race engine will pay for a lifetime of oil analysis. You'll never outspend that. Over years, saving one engine. And
so when would be the good time then to do your own oil analysis? You mentioned temperature, you mentioned drivers having influence. So when would be a good time? How many hours you need in the engines, how many miles? Is there a better time to do the analysis than during the weekend, or you wait until the end of the race? What would be?
I would do it after the race. The best thing to do is to be able to take a sample after the race, typically at the racetrack. So I know there's several teams that we work with that have, they've even gone to the length of, purchasing the sampling pumps. Mm-hmm. So they can go in there into the dry sump tank right after the race is over, because everything's nice and warm still. Everything's still mixed properly. You just go to the dry sump tank and you put the dipstick down there and pull the pump and take your sample right there. Get back to the shop on Monday, drop it in the mail. If you pay for the expedited, 3-day processing, you drop it in the mail on Monday, then you'll have the results back by Wednesday. So before the next race, you can already know what to do. Now, that's the highest level of service. And if you're racing for millions of dollars and you have hundreds of thousands, if not millions of dollars of sponsorship on the line, I'd say that $120 is pretty much worth it, because you can't spend that much in a year doing it, but it could save you a championship. And we've actually seen it happen. We have a customer that they were able to save a championship they actually caught 3 potential failures in one season because the engine supplier had a problem, and they couldn't figure it out for a while, but it was very hidden. But eventually, because of their persistence and the oil analysis, they were able to prevent the failures. They were able to give the engine shop data that they could look at, and then they were finally able to isolate what was going on and fix the problem, so it doesn't happen anymore. Which is, in the day, what you really want to do, right? You just don't want to catch the problem. You want to solve the root cause. Right. So I'd say the easiest thing, like I said, for instance, is to do it after every race. But for some guys, that's maybe they're more grassroots amateur, they do it for fun. At that point, maybe if you don't change the oil after every race, if you're going to run multiple races, then do it every oil change. That way you can at least build that trend, because like Bill said, the trend analysis is so much more important than the single sample. You can get the Perry Mason, kind of moment every once in a while. Oh, there's a smoking gun. I found it. I'm a genius. I can tell you what's wrong from the one sample. More times than not, that's not the case. What you really want to see is that trend over time and know what you're looking at. That's where you see the most benefit.
Okay. Can you take us through the graphs that's behind you?
Yeah, sure.
What you extract from it, the information you're getting, and a little demo so people can understand.
Yes, yeah. I'll move out of the way by that. I'll try to point. There we go. I have to kind of look at it both ways. So we start off with basically the information, what the sample ID number is. So every sample's got its own unique identifying number. That's the kind of key thing that holds it all together, so you know what you got. And then the sample date.
If you have it on your desktop, might be easier if you share your desktop, or no. I mean, it's up to you. Just for people watching.
I'll do it this way, just because if I have to go find it, who knows where it's going to be, and I can point it out. So anyway, we start from the top down here, right? I'm going to find my finger, point it the right direction. Wrong way. There it is. Bingo. We're going to start with viscosity, which, like Bill said, is the most important characteristic of the oil. So we know from the report what the viscosity grade should be. So we can basically look at this and set a sample marker here based on, is it in grade or not? Every SAE grade has a high and low value. So if it's within that range, it's good. It's going to be green because it's good. In this case, this one's a little bit low. And the main reason for that is the fuel dilution. It's almost 2%. That's the reason why that one's just a little bit low. Right. And then oxidation value is the health of the oil. How long has it been run? Yeah. So in what conditions it's been run. So that's all about the health of the oil. And this one is still okay. It's not bad. Right. And then we also have water and glycol, again, contaminants. If you have a coolant leak, you can see that. So these are the ones that are like the biggest oil health ones. Right. If you get a problem in here, you're going to have problems below. So these are kind of like your first line of defense, where you want to know what's the most critical thing about the oil. Is it right? Is it in grade? Is it still okay? Is it contaminated? That's what you're going to learn right here. Then this is the additive package. Okay. So this is going to go through and tell you, okay, this is calcium. Well, what's calcium? Most people don't know. Well, it's a detergent, right? So we've got that listed over here. So it will show you what is what. Then you can kind of see all the different additives in the oil, what their job is. Then you get down here at the bottom and, okay, now I've got my wear metals, right? Iron, chromium, that can be a ring face coating. It can be other things, copper, tin, lead, aluminum. You can't see the rest of them, but there's a few more down there. And then the other part of it going back is the trend analysis. That's the real key, is looking at across, and we're using over here an algorithm to determine, hey, what's that deviation from these numbers? Because as long as they're not moving wildly up or down, because down can be just as bad as up, actually. Bill, why don't you talk to say, how can going down actually be a cause for concern?
Well, first of all, it depends on what you're looking at, but if you're going down,
iron, let's say you had iron trending at around like 20 for normal samples, then all of a sudden it goes to 40 and then to 60, then all of a sudden it drops back down to 15.
Well, I mean, there could be a number of reasons, but I would probably, initially go straight into a problem with our viscosity or our fuel. I mean, because what you're going to see is, and it could also be a filtration issue too, if you go back to that, but that's one of the things we can find out by having that data is it a filtration issue? But when you start to see, typically, well, you never want to see your wear metals trending up, but when they're trending down, it's one of those situations where I'd have to probably look at the rest of the data to try to figure it out. I don't know that I have one simple answer for it.
What I was hinting at is that one of the things people don't recognize about oil analysis is it can really only see particles up to maybe 10 microns. Yeah. So as the wear progresses, those particles can get bigger and bigger and bigger. And at some point, they can be so large that you don't see it in the oil analysis anymore. Like you can visibly see oil that looks like metallic paint, but the oil analysis comes back normal. Well, why is that? Well, it's because the wear has progressed to the point that the particles are so large you can't see it. And I've actually seen that happen on a couple of cases where that trend's going up, and then all of a sudden, magically, it cured itself. And then that's what Keith said.
And the worst part about
fix themselves. Doesn't happen.
No,
nothing happened.
And then you've got work hardened particles. You've actually got harder particles because now they're work hardened. They've actually been compressed into denser particles.
So, I mean, those are the things you want to kind of look at, is that the trend analysis is really the key. And again, you're looking at all these wear metals going across the board. You want to look at that fuel dilution. And that's the nice thing about the report is you don't have to be a chemist or an analyst to read the report and make sense of it. If it's in green, it's good. And one thing too is, because again, Keith's got the expertise and background on this. We've been doing this stuff together for a long time. I mean, all the engines we did together at Joe Gibbs Racing, they were Total Seal's first NASCAR customer, right, Keith?
Yes, they were. Yes, they are.
So we have the background, the algorithm behind this isn't based off of fleet stuff. Like the guy was talking about, we call it the
over the road,
the 18-wheelers, right? We don't base it off that. We base this off of really an algorithm that's been built off of a decade and a half of doing race engine samples from NASCAR to whatever else we get our hands on. All the testing we did out there at Ronnie Shaver's place on the little test engine at Driven and with Total Seal, we literally have thousands and thousands of dyno samples where we've been able to actually measure the parts, right? So you're not just taking the sample and say, well, this looks like it's good. The other part of it is we were actually measuring parts. So we could, for example, just back last summer, we did the gas-ported ring test. And we ran these tests, a 16th, 16th, 3/16 ring package versus a 0.7 millimeter, 0.7 millimeter, 2 millimeter ring package. And of course, we saw all the horsepower difference. We saw the blow-by difference. We also saw a difference in the wear metals because that bigger, heavier ring wore the ring, the cylinders more. And it showed up in the oil analysis. You could see that, it was almost double. I think it was actually double the amount of iron, which is from the cylinder bore, just by making those changes. So when you have the ability to measure the parts and measure the oil, then you get that real strong correlation so that we can actually tell you, not just on, the book says it's this. No, we can say, well, we've seen this before in another engine, and this is what it's telling us. Because really, like you said there, Bill, one sample doesn't tell you that much. And in this case, we may be able to come back to the question because we don't know enough, because you're never going to know all the answers. This isn't fortune telling or palm reading or something like that. We're going to.
I was going to say, to your point on that, that's really key when you look at that algorithm, because I've been involved in an oil analysis for 20 years on, like the question we had on diesel trucks, locomotives. So the parameters that are set up, a diesel truck isn't going to get probably flagged for the same level or whatever that, a race motor will, or the fuel dilution maybe not be tested, to the same level. So when you don't have an algorithm or a set, we said one oil analysis doesn't mean anything. Well, you've got a lot of oil analysis, years of data that is reflective of the actual application, which is a high performance race engine. So you're going to pick, that's going to pick things up that, maybe, a diesel truck could have tons of wear that, we look at it and go, wow, but in that environment, it might be somewhat normal or not something to be concerned about. And that's a really good point to mention when you talk about, that is having that data that is specific to the application that we're sampling.
So that's a good point, Bill. It's because we're not comparing it to just that generic standard.
Yeah.
When you get one of these, you are comparing it to an actual race engine. So, and depending upon what kind of engine it is, I mean, we do a lot with the guys at LN. We do a lot of Porsche stuff. So if you send us a flat 6 Porsche sample, guess what? We know exactly what it should look like.
What it should look like.
So my question is, if you doing sports car, 24 hours of Daytona, you're doing, a NASCAR or whatever. I mean, you're basically going to be able to get a report based on the type of engines you're running, correct?
Yes, sir. You'll get a report based on the type of engine you're running, based on the oil you're running, right? Because we'll actually change up the specs based on what oil you're running. If we know what that oil is, if we know what the oxidation value of that oil is brand new, now we can do it versus that oil, not versus just a generic standard. So we can really dial it in. And then obviously you can look at the wear per 1,000 miles. You can look at wear per 100 miles and know what kind of fuel as well, right? So we know that there's a difference between a methanol fuel and unleaded fuel or a leaded fuel. Those are all going to change things up. So we get it very specific. The more information we have on the front side, the more information we can give back to the customer in terms of being able to hone in on what's going on. And, and Keith, I know we see this fairly regularly. Let's say you're in Australia or something like that. You're not here in the US where this service is. That's fine. You can still send us, take the samples. You use who's available for you, because we've had that before, haven't we, Keith? Where we've had the customer send us something.
I did, working with some of the teams down there, and this is a perfect, we'll say, segue into this, because we know what ring pack they're running. In this particular case, it's a 0.7, 0.72 millimeter ring package. And yet there's things happening in the engine that, from a ring point of view, it's like, nah, this is not a ring thing. This is another thing. And once we started working with the oil samples and getting that trend, looking at wear metals, it's like, for that style of ring package in a small Chevrolet based engine, we're seeing way too much wear metal here. And what this came down to was going back to the oil company. Their sponsored oil company made a change in the oil. And guess what? We're not, the friction reduction that we're expecting in that oil, it's not doing its job. So their engine problems really all came down to an oil problem of the oil simply just not doing the job that it was expected to do.
Oh, yeah. And that's a perfect segue into Dean Harvey's question. Would it pay to do a before you run analysis on new oil? Yes. Yeah. You want to know what you've got. Because then that reference is going to tell you more than anything else. Because if you're just looking at it generically, any change in oxidation or viscosity is not as close. But if you have that new oil, then you can look at it and see, okay, this is the batch that I had. Now I can see any variation. Because one of the other things that we've come across, and Bill, I'm not sure if you've ever seen this happen or not, but a buddy of mine, Jake Raby, who does a lot of Porsche stuff, he noticed a trend years ago, and he kind of pointed it out to me. I was like, I was kind of curious about that too, because I've seen it before. Not very often, but I've seen it before. That in the early stages of an engine experiencing premature wear, the phosphorus in the oil is being consumed. So let's say that oil new is normally, say, 1,000 parts per million phosphorus. before it ever goes crazy with wear metals, that phosphorus level might drop to say 800. Because it's like the oil is doing everything it can to try to save that engine from dying. But at some point, it just runs out of gas, and then the wear takes off.
Yeah, you're experiencing more boundary lubrication somewhere, maybe somewhere you don't quite want it, and so
right.
your ZDP, your FOS is activating, your ZDP is doing what it's supposed to, and it's getting depleted quickly, and that's, it's almost like a segue again. Another thing that oil analysis tells us is your additive levels and additive depletion levels. We use it as a tool here with a lot of our customers. And one of the benefits, to go back to the previous thing, was, I know our formulations. I know what they're all supposed to be. I know what they're all supposed to look like. So I can interpret through some of the data a little differently because I know my raw materials and my starting point. But, if you have, a situation where, all of a sudden one of the additives starts looking weird, that's just that gets you to that preventative, predictive point quicker, because wear metals are going to go one way, additive levels are going to go one way. So all of a sudden now we're able to really look at it from a little bit pulled back perspective, and that's the key. That's the whole key to this, is trying to find out that problem before you have it.
Oh, one thing we've seen this used for before is every once in a while, somebody will put the wrong oil in the engine.
Oh, absolutely. Yeah. Yeah.
And it will stick out like a sore thumb if you already have that new oil sample. This is what's supposed to be in the engine, and this is what came out of the engine, and they're not the same thing. Then you can know. It's like, okay, well, it wasn't the engine guy's fault. It wasn't the piston ring's fault, for a change, right? It actually wasn't. It was the fact the guy put the wrong. I mean, we literally had this is years and years ago. The drums of XP1 had blue lids on them. Mm-hmm. The drums of the 75 110 gear oil had blue lids on them. Anyone want to guess where we're going with this? We go to Charlotte, and engines are blowing up left and right. And the engine guy comes down and he's about to choke me to death. He's like, every engine we got is blowing up. And we're like, let's go look at it. And we go look over there. Of course, I walk up before I even get there. I can see it, because the gear oil is a different color. It's very light color versus the XP1, which is a darker color. I'm like, that's gear oil. What?
We got a question from Kyle. What is the best way to take a sample to ensure accuracy?
Wow.
Okay. Well, from a engine, the engine needs to be warmed up, have been run fully up to temperature. Because here's what happened, right? Back to fuel dilution, right? Here's a way to get a false positive on fuel dilution. Is to go out in your garage, crank it up, and let it run for a minute and pull a sample. Because, Keith, what does your ECU do when you crank the car up? Why don't you tell them real quick?
Oh yeah, you're going into the startup mode, and just like pulling the choke on your carburetor, she's putting a whole lot of fuel in there to get her started up. Yep.
So you'll dump a bunch of fuel in the oil, take the sample, and guess what? The engine's not gotten warm enough yet to actually get the fuel gone. You put a bunch of fuel in it, so you'll get a false positive. So the best way to get the accurate reading is to get the engine fully up to temperature. And then what I always would do, it's easier on the dyno than it is anywhere else. I start a 3-minute clock. From the time I turn the key off, the ignition's off, 3 minutes, pull the drain plug. Count to 3 Mississippi. Mm-hmm. 1 Mississippi, 2 Mississippi, 3 Mississippi. Put the sample bottle in midstream, take the sample. Fill the bottle 3/4 full, close it, because when it gets to the lab, we got to shake it back up because it's going to settle. So you don't want it full because you would like to have some space in the bottle in order so when they shake it up, it can be agitated to really get the metals to mix well. Because an improperly taken sample, and I see Bill nodding his head. What's the problem with improper sample, Bill?
It's going to give you improper results. And I can tell you, I had a customer one time that was doing a lot of oil sampling. All of a sudden, boom, wear metals were through the roof, just through the roof on a bunch of different units. They had a new guy in the shop, and he was doing what he was supposed to. He was taking an oil sample, but the second he pulled that drain plug out, he threw that bottle up underneath there. I mean, literally catching the oil almost as it was pouring out. So he was just getting everything right off the bottom of that pan in every sample. The wear metals went through the roof, and it took us a while to actually figure out, that was what was happening. But when you do an oil analysis, and this is, Lake and I this goes back to all of our training with the STLE, the Society of Tribologists and Lubrication Engineers. What we need is a representative sample. So you want to picture trying to get a sample out of the middle of the oil in the oil pan at proper, at operating temperature as close as you can, and keeping that consistent, because going back to that wear, trend analysis, all these great things we can do, lower your viscosity, increase your horsepower safely, all the stuff that everybody wants to do. The consistency is key to having that data consistent.
Yeah, exactly. Yeah, it's almost like anything, right? In an engine and in any kind of scientific method, you have to be consistent in your procedure. It's just as important as anything else, because if you vary on that, then your results are going to vary, and now your data isn't trustworthy. And the whole thing we're trying to do here is build that database, and then you can tap in to this existing database in order to move your program forward, because like Keith said, it can help you find things you wouldn't have found otherwise. I mean, because without the oil analysis, they would have never even thought to look for that, would they?
Well, I'm gonna play tourist here. I'm gonna throw a question out because I got two great oil guys right here. I deal with a lot of engines, a lot of builders out there that use, we'll say, mechanical injected alcohol engines. So we're talking, copious amounts of fuel going through these things. And there's kind of I don't want to call it a wives' tale, myth, whatever. And it's like, we know there's a lot of brands of oil out there. And we'll just say, I know where I lie, but I can't use that brand because it doesn't keep fuel in suspension. And that brand doesn't keep the fuel in suspension. What's the truth? Truth and lie. What is there a difference? And if so, what keeps that fuel in suspension versus letting it get mixed in with the oil?
I have an answer.
You go first. I'll let you go first.
Fair enough. So temperature, we'll go back to that once you reach about 180 degrees Fahrenheit, which is pretty much close to the boiling point of methanol, that fuel should go away. That's one thing, again, all the time out at Ronnie Shaver's place with Dyno Don on the dyno. It's everything we can do. One thing he does, by the way, in terms of their break-in procedure, is the fuel flow valve on that mechanical system, he only puts it halfway. That valve's not wide open. So he's running it with less fuel flow possible to the injector system, because it can be a little bit lean because he's not putting any load on the engine. And it helps the engine come up to temperature faster and put less fuel in the oil. Once the engine's fully up to temperature, he's at 180 degrees Fahrenheit oil temperature. And oil temperature is the key. You got to measure oil temperature. If you're just basing your oil temperature off water temperature, you are lost, because you can be 30 degrees under your water temperature on oil temperature in a short run application. Now, in an endurance application, it'll probably be 30, 40 degrees hotter than your water temperature. So to really do this right, you need to have a measurement on your oil temperature. Once that oil's at the temperature, open the valve wide open, they can go ahead and start making their runs. Everything's good, and there's no issue. So from a mechanical standpoint, just leaving the oil chemistry out, there is a right way, a better way of doing it to keep that fuel dilution down. And part of it is using the oil temperature as your help. The second part of it is the chemistry of the oil. And that's where the detergent package in the oil is everything. If you have a lot of detergent, a lot of dispersant, like say a diesel oil, it will, we all call milk up. And we've all heard people use that term. We've probably all seen it. Oil that looks milky. Well, the oil looks milky because it's suspending, back to what Bill was talking about earlier, the free fuel versus emulsified fuel. Those agents are emulsifiers, and they hold it in suspension. And fuel is a really bad lubricant. Methanol, especially bad lubricant. So you want an oil that has low levels of detergent and dispersant so it doesn't want to milk up. That's the key in those applications, where you, especially when you don't have heat. But even when you do have heat, you'll find that some oils, and I don't know if, Bill, you've come across this or not, but I've seen it happen a couple of times. An oil can have so much detergent, so much dispersant, that even with the temperature, you can't break the emulsion. It doesn't want to give up.
No, and actually we've done that here, and I've been working on that even recently, because the other thing that you'll find is alcohol is polar to water. So they'll mix, they like each other. So when you've got, say you've got a lot of, free alcohol, dilution, and then you've got a lot of detergency, and then you just get a little moisture in there, and you get moisture comes in engines from combustion. It comes in from all these different ways. You've just created an emulsion cocktail. You've put everything there you need to mix all of that together. And what literally we've just been, it's one of the things we're working on because of the prevalence of E85. And this is more for the street guys, but running LS motors, twin turbos, going to E85, and not thinking about what impact that has on the oil. But what you'll see is when you add a little bit of moisture to an alcohol and a high detergent oil, it blends together. It creates an emulsion that does not break. And that all of that becomes a precursor to the other additives, the ZDDP, everything. It's a catalyst to cause it to go, south pretty fast. Yeah. So yeah, I mean, it's exactly like Lake said, it's temperature, it's mechanical, but and if you think about it, when we race, it's always the hottest, most humid time, of the year. There's a lot of moisture in the air. And if you don't change your oil after, say, your event, like, and you put the car back on the trailer and it sits there 2 weeks and you go out and run it again, well, in that 2 weeks, it's literally, drawing moisture in. So you're just, kind of adding to that problem. And we see that quite a bit.
I'm sure it can cause a lot of rust issues too.
Absolutely. Absolutely.
And just, what I'm, gleaning from all of this, and this is something that, people out there really, if they don't get this, they need to understand this, that, getting that oil up to temperature to get the fuel vapor, the water vapor, to get all of this out is super critical. I had a customer this last summer, drag race guy, and we as drag racers are all on to, man, we got to keep that engine cold. It makes power. You got to keep that intake manifold cold. So we keep this thing cold. Well, at the professional levels, they're chilling the cooling system and they're heating the oiling system. But this gentleman didn't have that. He just iced everything down, kept it cold. Well, after about 5 weekends of racing, it's literally rusted the rings together. He jumped this engine because that oil is expensive. I'm not going to change it every weekend. Right. So
and
that's, we just had lesson learned there. You got to get that oil up to temperature.
Yeah. And like I said, so detergent helps prevent rust and corrosion. In a racing oil, though, you don't want a lot of detergent because it is also a surface active chemical that's going to get in the way of your ZDP and your moly and all that good stuff. They're going to compete for the same surface area. So it's a real balance. But if you lower your detergency, you're kind of lowering your rust and corrosion protection, but you need to kind of lower that detergency to keep it from emulsifying with all the water and the fuel. So it's kind of one of those situations where, I hate to say it, being in the oil business, I don't always like to sound like I'm trying to sell everybody oil, but it's a lot of times change the oil. It may not be a function of the actual this brand A, brand B, whatever. It's a fact of the application that you're in. It's and the environment that you're creating based on what you're doing.
Exactly. Well, and the thing is, we want to mention to warm up your engine, you're not going to warm it up idling it. Idling your engine is the worst thing you can do for your engine. It is death for a performance engine. And I know people like to warm them up and fire them up and let the buddies hear the cam in the garage and all that, and it's cool. But you got to realize that every time you're making the cool sound, you're actually kind of killing your engine. That engine is a thoroughbred. It's designed to race. It needs to get warmed up and go. Don't be afraid of it. Don't baby it. mean, I know, Keith, let's talk about that first real quick. I only got, I know, a couple minutes left, Francine, but proper break-in procedure is key. And way too many times people baby stuff when they shouldn't.
Mm-hmm.
Yeah, that's exactly right. Again, we can all go back and recall conversations. I had a gentleman yesterday building high-end Harley Davidsons, 4,600 bore, 8,000 RPM, all this stuff. And, we went over, rings and cylinder bore prep and, a whole lot of things. And then I brought up, well, how do you break it in? Oh, we've got a dyno. Okay, engine dyno or wheel dyno? Wheel dyno, okay. Well, run me through your break-in process. Well, I run it for 10 minutes and I let it get up to XYZ temperature. I go, what temp? How do you check on that temperature? Oh, I got a laser temp gun. Okay. I go, what do you do after that 10 minutes? Well, then you got to let it cool down. And he goes through these 5 different heating and cooling cycles for this engine to a total of about an hour's time, never having put a load on it.
Ooh.
This is the baseline of the issues the gentleman's having. We converse like, no, you got that dyno, light it up. As soon as you've got reasonable oil and water temperature in it, get after it. Put some load on that thing. I don't care if it's a Harley, a Honda, helicopter, whatever. You want to get that engine on there and get a load on it as quickly as you can safely. Do not let it sit there idling.
Right.
Well, thank you so much. That was fascinating. Again, I stepped in for Brad Gilly, who had last minute situation. I enjoyed so much.
You're a great host, Francine. You're a natural.
I mean, I just know, but usually we on the back end because we have to get prepared for the next webinars, bring people on, and so I listen to everything, but I can't pay as much attention as I had to pay attention on this one. And it's fascinating. And that's what it makes our job so cool, because we talk with you. Then the next thing is NASCAR, before was drag racing, earlier was F1 rally or whatever. And that makes our job so cool and so great, because we have the opportunity to interact with all of you. But again, thank you so much, Blake, Keith, Bill, and being with us. We have pushed a SPEEDiagnostix product back on the homepage of EPARTRADE, so you can see all of a SPEEDiagnostix product as well as Driven as product. We came on board recently, so we're very much appreciative of that. And of course, Total Seal has been supporting us since day one, so we could not be here without the help and the support of the industry and all the suppliers are showcasing on this platform, and of course our sponsors this week. So thank you very much.
The concept for EPARTRADE is basically, in my opinion, there's a big hole in the internet. So the internet started many years ago, but there's never been an online business community for racers on the World Wide Web. The need for EPARTRADE is actually quite obvious. Basically, people in the business of auto racing need a place online to hang out and get their problems solved.
It's extremely simple for a buyer or for a supplier to interact on the platform. The first thing you need to do is sign in, which is free. And the second thing is, when you see a product that you're interested in, all you need to do is click on request more information. If it's a company, you click on request more information, and then from there it is forwarded directly to the buyer or to the supplier.
You can go to epartrade.com, you become part of a community of businesses in racing, and it makes sourcing products much easier than just on the internet or using Google.
At EPARTRADE, there is no e-commerce. It's literally a connection, just like at a trade show. So now, any time of the year, a buyer could reach out to a supplier through an email.
More than that, it's a place to go just to keep current every day. So it's a good place to start your workday in your racing business or in your offices of your professional race team. And you're current when it comes to new technology, industry news, technical papers, technical videos, all of that and more. We're not looking for a million hits per day. All we want is people who are really the volume buyers of racing products in the racing industry to be part of the little world of EPARTRADE. We have racing businesses participating from around the world. So you get suppliers from around the world, you get buyers from around the world.
EPARTRADE really eliminates having to travel, closing down your shop. Now you have a place to showcase globally your racing product and technology.
There are two types of people, racers and everyone else. Racer Magazine is for those who believe that racing is a way of life. Racer embodies the excellence that defines a sport driven by passion, courage, and ingenuity. Get 1 year of both Racer's print and digital edition for only $39 with instant access to our entire digital issue archive. Subscribe now at info.racer.com.